Okay.
Hi guys, my name is Olga. I'm a UX designer at AWS, and this is my colleague Thomas. We created a team responsible for making developers' lives easier.
So we did that beginning last year, this year, sorry. Sorry, last year for me. No, this year. And we want to tell you what we learned along that way in the last couple of months. And we want to talk about the first project we actually did in AWS. And I will start by explaining why there's it's a big challenge to create user interfaces at a large scale. So you probably kind of have used some of our services before. They're pretty massive, but there's also a pretty impressive aspect to creating user interfaces. After that, Olga will continue with the web components part of the talk, why that failed, and what we did instead. So let me start with talking about Amazon Web Services. Thank you. We as an organization are split into very small, different, independent teams, and each team can work independently of each other. And the purpose of each team is to create a service for our customers or for other teams internally. And the challenge there is how all of these build their products. And we don't have any speaker notes. But there's also an upside to kind of the structure. So there's a couple of different things that make us stick to this operational structure, which is like kind of each team can independently decide on what they do and what technologies they use to solve that problem. And
sorry, we're having technical difficulties here.
If you already would see the next slide, I can continue probably.
Oh, sorry. Okay. Now
that's a speaker note. That's cheating. Don't read this.
There we go.
There we are.
Okay.
So the next slide. Awesome. We measured the success, for example, also in our output. So last year, I'm not sure if you followed what we're doing. Last year, we launched 516 larger interface features or like kind of product features, or even completely new services. That kind of comes down to about 1.5 large deployments to our interface, which you might have seen. And I'm not talking about all the other small deployments we are doing. So if you follow like kind of other talks of us, or if you've seen other talks, like kind of the amount of deployments we do every day is just mind-blowing. I still don't get really how we do that. But one part of that is that organizational structure where we have all these tiny independent teams that can decide on their technology completely, like kind of their frameworks, stuff they want to use to be most effective. The thing is, that comes with a challenge, right? Like kind of most other large companies, we have a design guide. But we don't have a design guide and one team implementing the design guide. We have a ton of different teams that try to implement the design guide. And guess what? Like we talked about that. Just there's, right? Like kind of there's, okay, this needs to be blue and it has rounded corners. How round are they? Like kind of where's the icon? All of this, right? Like kind of most of that stuff is actually specified, but not all of that, because not all designers understand how to implement that, and also not everybody that implements understands design. So that's actual live examples, and we thought we have to do something about that. And the first project we were creating is like kind of the idea to design as code, so similar as configuration as code. We just picked that up and wanted to improve on that. So the idea was to build something in code that is always in line with our design guides and then works across all different frameworks. Because our reality is that people use JavaScript, Angular, whatnot. Like kind of they pick their tools. And it needs to be easy to integrate in whatever is existing already, independent of the technology stack teams are using. And this is how we started our first experiment, and I hand over.
Okay, so when you think about these requirements, what comes to your mind immediately is, oh, we're going to use web components. Because what is web components? Well, it's a series of technologies, custom elements, shadow DOM, HTML imports, and templates. And you can think of them as reusable user interface widgets that are encapsulated and basically reusable. So this is what we would like to use. The two most interesting technologies that are part of web components is, for us, shadow DOM and custom elements, because this is exactly what we would like to use when building our components. And this basically solves our problem. So what is shadow DOM? Shadow DOM offers encapsulation of CSS, templates, and JavaScript in a DOM node. So this is pretty cool. Now we have custom elements. Custom elements basically allow you to create your own HTML tags. So looking at the custom elements, what can you do with them? So basically, you can say, instead of a select, you can create an AWS UI select. And that select can behave in a completely different way. Inside that select, you can have, instead of normal options that behave and look in a given way, you can have AWS UI options. And that is pretty cool. But you might think, okay, why do we actually need those custom elements? Because it was already possible beforehand to add your own custom tags to HTML, and your browser would render them, and they would behave in a given way, and you would be able to style them even. So the really cool thing about using custom elements is that by using them, you get lifecycle callbacks. So what are they? Actually, lifecycle callbacks, they notify you once something happens to your element. So when your element is created, you get a created callback. When your element is added to the document, you get an attached callback. And at this point, you might want to add some event listeners, you might want to notify the element's parent that the element has been created, and so on. Also, same thing happens when you remove your element from view. You get a detached callback. At this point, you might handle garbage collection, you might do memory management, you might want to remove the event handlers that you created. It's all cool. And this actually you get only when you use custom elements. So what happens if you register an element in the browser is that it uses the HTML element interface instead of using the HTML unknown element interface when you actually don't use custom elements. So this is what makes it so cool. But looking at the specification status, so at the browser support, we see that both Shadow DOM and custom elements are supported in Chrome, but in Firefox they're behind a feature flag, and we can see that the standard is just not there yet. So what we tried doing was using polyfills to basically backfill that missing browser functionality. So you most probably know Web Components JS. It's this polyfill for all technologies that are under Web Components. But if you don't want to use a full polyfill, you can also choose to use a smaller one. So we chose to use document register element as a polyfill for custom elements. And those polyfills are really good. I mean, they work great, but mostly when they're used as a main framework in your application. If you try using them with different frameworks, so in our case, we tried using them with Angular, you run to all sorts of problems with those polyfills. So what are those problems? Basically, all polyfills use mutation observers. So mutation observers check all the time whether there has been a change to your component. So how it works is, in practice, is if your component changes, you want to be notified about it. But the mutation observers don't only observe components, they observe your whole DOM. So this obviously has an impact on performance. Mutation observers are also different from native, so they work asynchronously. So when you add a component or change an attribute, you'll get notified about it, but maybe a bit later. Once you call a function, you get notified immediately. So it works a little bit differently and can cause a lot of problems when actually using that together with frameworks that rely on certain things being done at certain points. Also, the implementation differs per browser. So not all browsers support mutation observers. Some of them support an older technology that is called mutation events. And those mutation events, they work synchronously. So not only do we have to care about if we do the native thing or if we use mutation observers, but also about the version of the browser that we're actually using, because we might end up using something completely different. So to summarize, web components are not there yet. We can't use them to solve our problems. We were also unable to use the polyfills because they just didn't play nicely with the frameworks that we were using. But what we found out is the concepts that are used in web components are really good concepts. So we started looking into actually using those concepts to build our own custom elements. And this is how our second experiment started. So let's build a component together. This is an AWS UI alert. You see alerts quite often. You use them to notify your users about something in your application. In terms of the visuals, this is how we could define an alert, and this is also what our design guide says an alert should look like. Okay, let's try to build an alert. So first thing we need to do is we need to create the element. But we would like to be able to use it exactly in the same way as we would use a custom element. So we would like to get the lifecycle callbacks. So what we need to do first is call create element. Then we need to append that element to the body. And then because we don't have web components, we need to call has been attached to do exactly the same as the created callback. At the end, we only get a DOM node, so we get an alert similar to this. That's all cool, but now we would like to be able to interact with our component somehow. We would like to maybe be able to change how it looks and how it behaves. So for that, we have defined two properties. We have a type and dismissible. The type defines the nature of the alert to be displayed, so success, error, info, warning, whatever we want. And the dismissible, if you set it, it basically shows a little control in the UI that allows the user to dismiss the alert. So let's have a look at actually interacting with that component. Let's say we don't want to have an info alert. So instead of the blue box, we would like it to be red. So let's say it's error. So the component changed the color to red from blue. So we can say we have an error alert. What if we want to make it dismissible? Well, then we just say alert.dismissible is true. There we go, and it gets the little icon, so now users can dismiss our alert. Speaking of interacting with components, so actually maybe in our UI we would like to be able to dismiss the alert if a user clicks an acknowledge button, let's say. So we would like to be able to do something similar to this. So for that, we have defined a dismiss function that basically removes the alert from view once the user clicks it. But it's all super cool, right? It works, but you would like to be able not only to pass in properties and strings, but maybe also be able to pass in HTML to your alert, right? Maybe you want to say something like, I want to set the header and say the header is rocks. And the content of your alert might be something using HTML, so I'm going to say it's minerals in bold. So you can pass in any HTML. And how did we do it? Well, we added support for regions. And what those regions do is basically, instead of just taking a string, they take a whole DOM node, and they render the DOM node as is. So thanks to that, you can actually enter HTML to our components. Okay. Then obviously, maybe you would like to get notified if something happens to your alert. So when the user dismisses it, maybe you would like to know about it, maybe to store it somewhere as a preference that a certain user has dismissed this type of alert to never show it again. Or maybe if somebody clicks a button, you would also like to be notified about that. You can basically add event listeners to our elements. This is pretty easy. So let me demo that. So let's say if a user dismisses this alert, we would like to see the browser native alert on the screen, and it should say oops. So exactly what the function says. Okay, that worked. So you can interact with our with our components. So to summarize, we have a complete component now. We deal with the lifecycle. We create the element. We append it to the body. We call the lifecycle callback. Then we set the type of the alert. We can say maybe it's a success, maybe the alert is dismissible if we want to allow users to dismiss the alert. Then we set the region, so we pass in some HTML, we set the header, and then we add some event listeners to our element. That's all cool, but how do we actually make sure that the component is being rendered on the page? So for that, we use reactive DOM rendering. So looking at our alert, let's say it would like to, it has some content in it, right? But we would like to also be able to set the header. But we don't want to render the header if it's not there. So what we want to do is, if the user sets a header in our alert, we would like to render an icon. We would like to show the header text, right? Let me demo exactly what we would like to do. So as you can see in the demo, the icon class and the header appeared only after I have added a header. Let me remove it and try it again. So this is pretty cool because we only manipulate the element when it's actually needed. we don't add those things when they're not needed in the element. So what else does the component need? It also needs styles, so it has to look in a certain way. So what we know about our users is that they're not going to rebuild their whole applications from scratch. They're not gonna, if they want to use our components, they won't build a whole new thing, but we actually have to integrate with their existing code. What it means for us is that we can't break people with our components, so if they want to use our components, we can't break their code and introduce some weird behaviors. But what it also means for us is that people are going to have styles that might leak into our components, that might break our components. So how did we deal with that? So basically we have two rules. One rule is if you want to use your component, you need to use it in a div or in an element basically in your application that uses an AWS UI class. So that way you can use your element quite safely, because if there is a place in your app that is obviously broken, if you add our element or our styles, this wouldn't happen. So one thing is like using our elements in a given scope. Then the second thing we do, and you can see that here, is, for example, let's say you use an icon class in your CSS. And obviously that icon class has some styles tied to it. What we don't want to do is we don't want to break your icon class. So if we add our own styles, we don't want to break the code for you. So what we did in the component is, so in this case, this is an alert. We prefix all class names in the component with the name of the component. So that way we can make sure none of our styles actually leak out of the component and we don't break your code. So looking at the component again, right? This is what you would have to write in order to use your component. You would have to create the element, append it to the body, and then call has been attached, and so on and so on. While this works, I wouldn't really call it super easy to use. I wouldn't want to use that. I bet as an Angular developer, for example, you would rather write something like this. This is so much shorter and so much better. I'd love to use this instead of the thing on the top. So how do we do that? For that, we have created something that we called framework wrappers. And what are these wrappers? Well, they allow you to use the components natively in any framework. And because that lifecycle management is pretty complicated, you don't want to do it manually. You don't want to call has been attached or has been detached every time you delete the component. So what happens is the wrapper code takes care of that logic. What we currently have is an Angular GWT, and we're planning on adding more wrappers, like for React and also for web components. But you might ask, like, how much overhead is that? How much work do I need to do to add this wrapper? Well, those wrappers are actually quite small and compact. It's only a couple of hundreds of lines of code for every wrapper, but it adds the support of using those components natively in every framework. And also, this is an extra, those wrappers are not done manually, so they're actually generated automatically out of the component code. So how do we do that? Well, every component has an official description. That description we call component definition. In the component definition, we talk about all the properties, functions, events, and regions that a single component has, and we also add some useful typing information. So, for example, if you haven't defined a property and this property is required, you'll get warned about it. So it's not that it will fail silently and you wouldn't know. So these component definitions, they're used to generate the framework wrappers, but we can actually also do more with those component definitions. We use them to generate documentation for every component, as well as generate tests. So now to evaluate our experiments, has it been successful? Do we think that design as code has worked for us? We think it has. So since, I think, July 29th, teams have been using our components in production, and they're actually liking our components. So there's an actual quote from a developer, and the person claims that we have helped their team to write reusable code and styles. And thanks to using our components, they're also right now 100% compatible with the AWS design guide. So this is pretty good. What you can see in the background is a graph that shows interactions of customers with our components. And you can see that the tendency is growing. That looks pretty good to me. But we're not going to stop here. So, yeah, we're not going to stop here. I'm saying thank you, but it's not a thank you yet. we have a lot of more frameworks to support and a lot of more components to add. And actually, we're hoping you'll be able to give us also feedback on the components and that you'll be actually able to use our components very soon because we're planning to open source them. If you have any questions, would like to talk to us about the components, please do. We're available during the breaks and also later tonight. And Thomas is showing the little chocolate guy, so the orange dude. Try to look for the orange dude to find us during the breaks. Thank you very much.